Assalamu alaikum wa rahmatullahi wa barakatuh. We return back to MCQ for medical laboratory scientist and technologist for license exam part 5. First question, calculate the mean cell hemoglobin concentration MCHC using the following values. Hemoglobin is 15 gram per deciliter, hematocrit 47 milli per deciliter, RBCs count 4.5 by 10 to the power 6 microliter. And the possible answer is 9.5%, 10.4, 31.9, 33.3. So now how we can calculate the MCHC. MCHC is calculated through the following equation. Hemoglobin divided by hematocrit multiplied by 100. This is the equation for MCHC. So now hemoglobin is 15. So 15 divided by hematocrit, which is 47, and multiplied by 100. It will give you 31.9%. So the correct answer is C, 31.9. So if I add one more question here, if this is the result for MCHC, can you tell this one is hypochromic or hyperchromic or normochromic? 31.9. Which of these? We should know that the normal value of MCHC is between 32 to 36. So this means 31.9 is low. So here it will be hypochromic. Question number 2. A manual white blood cells count was performed. A total 36 cells were counted in all 9 millimeter square of a Neuber ruled hemocytometer. A 1 to 10 dilution was used. What is the white blood cells count? So the equation to be used is number of white blood cells counted multiplied by dilution and divided by number of squares counted multiply by area. So how we will do this calculation? Now, what is the number of cells counted? 36. Then 36. You will multiply by the dilution factor, which is 10, and divided by the number of squares counted, which is 9. Then you will multiply by the depth of the hemocytometer, which is 0.1. This total is the area. So it will be 36 multiplied by 10 and another 10. You will take it from 0.1, you will reverse it, divided by 9. Remove 9 and here it will be 4. 4 multiplied by 10 and 10, so it will be 400 per cubic millimeter. Okay, again 36, you will multiply by 10 dilution divided by 9 and multiply by 0.1, which is the depth of the hemocytometer, and this the number of squares counted. Then it will be 36 by 10 divided by 9, and this 0.1 you will reverse it, so it will be 10 up again. By calculation, it will be 400 per cubic millimeter. Okay, so 400 per cubic millimeter, it is equal 0.4 liter. So A is the correct answer. Next question, a 7 ml EDTA tube is received in the laboratory containing only 2 ml blood. If the laboratory is using manual techniques, which of the following tests will most likely to be erroneous? RBCs count, hemoglobin, hematocrit, or white blood cells? When we add less volume in anticoagulant tube, now the ratio of anticoagulant to the volume of blood is more. And we know that excessive anticoagulant will make shrinkage of the RBCs, which will affect the hematocrit, while RBCs count, white blood cells count, and the hemoglobin content will be same. Don't forget here, this EDTA is not liquid EDTA. It is dry EDTA. Otherwise, if it is liquid, it will affect all the parameters, because the dilution here will make the count is less. But here, because it is dry EDTA, it will affect only hematocrit, but the count here and hemoglobin will be the same. Next question, if a patient has a reticulocyte count 7% and an hematocrit is 20%, 20% is very low, so this means the patient is anemic. What is the corrected reticulocyte? If hematocrit is very low, this means we need to correct the number of reticulocyte. Okay, the corrected reticulocyte count using the following equation: retics count multiplied by hematocrit and divided by 45. This is the equation to correct the retics. This means the corrected retics will equal 7 multiplied by 20 over 45. It will be 3.1. So 7% is not the accurate reticulocyte content because of low hematocrit. The corrected and precise one is 3.1, which is B. Next question. A decreased osmotic fragility test would be associated with which of the following conditions? Sickle cell anemia, hereditary spherocytosis, hemolytic disease, of the newborn acquired hemolytic anemia? The correct answer here, osmotic fragility will decrease in sickle cell anemia, while spherocytosis, hemolytic disease of newborn, and acquired hemolytic anemia will increase the osmotic fragility. So the correct answer is A. Sickle cell anemia will decrease the osmotic fragility. Next question. A falsely elevated hematocrit is obtained. Which of the following calculated value will not be affected? Which one of these will not be affected with falsely elevated hematocrit? We should know that MCV is calculated by hematocrit multiplied by 10 divided by RBCs. So the equation include hematocrit. So MCV will be affected by false elevated hematocrit. What about MCHC? MCHC is calculated by hemoglobin multiplied by 100 divided by hematocrit. The equation includes hematocrit. So also MCHC will be affected by falsely elevated hematocrit. What about red cell distribution weights? Red cell distribution weights in automated machines, it is based on MCV calculation, which will be affected by the hematocrit. So also red cell distribution weights will be affected by hematocrit. So what about MCH? MCH is calculated by hemoglobin multiplied by 10 divided by RBCs count. Here the equation doesn't include hematocrit. So the only parameter is not affected by falsely elevated hematocrit is MCHC. Next question. You have a scenario or situation here. RBCs indices obtained on an anemic patient are as follows. MCV is 88 femtoliter. MCH is 30 picogram. MCHC is 34%. The RBCs on the peripheral smear would appear if you have these values for MCV 88, 30 for MCH, and for MCHC is 34. How the RBCs will appear on the blood film? Will appear microcytic hypochromic, microcytic normochromic, normocytic normochromic, or normocytic hypochromic. If we look here, MCV is normal because normal reference range 80 to 100. This one. MCH is 30, which also is normal. MCHC normal is from 32 to 37 to 36, which is 34, also normal. This means RBCs will appear normocytic, normochromic cells. So C is the correct answer. All the following factors may influence the erythrocyte sedimentation rate except one of these will not affect the ASR test. Here, blood drawn into sodium citrate tube, anisocytosis, picocytosis, plasma protein caliber of the test. Anisocytosis and picocytosis will affect the ESR. Plasma protein also will affect the ESR. Caliber of the tubes will also affect the ESR. So only draw the blood into sodium citrate will not affect the ESR test. Next question. What staining method is used most frequently to stain and manually count reticulocyte? Immunofluorescence stain, supravital stain, Romanowski stain, cytochemical stain. It is supravital stain, which include methylene blue. Next question. Using an electronic cell counter analyzer, an increase in red cell distribution widths should correlate with spherocytosis, anisocytosis, leukocytosis, presence of nucleated RBCs. If the red distribution widths increased, which one of these will lead to increasing the red distribution widths? Is the anisocytosis. Changing or varying and different sizes of cells will lead to increase the red distribution widths. Next question. A correlation is necessary for white blood cells count when nucleated RBCs are seen on the peripheral smear, because the white blood cells count would be falsely lower, the RBCs count is too low, nucleated RBCs are counted as leukocytes, nucleated RBCs are confused with giant platelets. When we have nucleated RBCs, the automated machine will count the nucleated RBCs as white blood cells. This means the count will be falsely high. So the blood film will help us to correlate the white blood cells count from the automated machine with the blood film and to see there is nucleated RBCs or not. Okay, so here's the correct answer is C, because the machine will count the nucleated RBCs as leukocyte. But in the new updated machines, all the new machines now, it is able to correct the white blood cells count in the presence of nucleated RBCs. So the count that you get it from the recent machines is the corrected white blood cells count. Given the following values, which set of red blood cells indices suggest spherocytosis? Spherocytosis, this means MCHC is more than 36. If we see here MCV 76, MCHC 19.9, MCHC is 28.5, MCV 90, MCH 30.5, MCHC is 32.5, MCV 80, MCH 36.5, MCHC is 39, MCV is 81, MCH is 29, MCHC is 34.8. So spherocytosis is the increase of MCHC, which is here because the normal from 32 to 36. So answer is C is the correct one, because here MCHC is 39, which is high. Which of the following statistical terms reflects the best index of precision when comparing two CBC parameters? Mean, median, coefficient of variation, standard variation. Coefficient of variation اللي هو CV% is the best statistical term. You can use it to detect the precision. So always we are monitoring CV% every month to see your analyte is precise or not. So the correct answer is C. Thank you and good luck. Please follow, like, share to the next video. Assalamu alaikum wa rahmatullahi wa barakatuh.